Before we move on from concentration of solutions, there's one more topic that we need to cover. And we'll start off with reviewing what a stock solution is. We define this stock solution as a concentrate. That's where a solution is to be diluted to use for experiments in laboratory. So in lab, we purchase large quantities of hydrochloric acid, for example, at 12 molar. And there we can dilute this and reduce it down to a lower molar quantity that we can use doing our experiments. So these stock solutions, they can save a lot of time. They can conserve materials, reduce the storage area for other chemicals. And after we dilute these concentrations, we call it a working solution. So we purchase large quantities of concentrated solutions of chemicals that we use over and over again. So the concentrated stock solution, we can lower these concentrations as needed, and we do this by dilution. A dilution process is where the concentrated solution is lowered by adding the solvent. Remember, the solvent is a larger part of the solution, for example, water. And we're going to add this without adding more solute. Solute's a smaller part of the solution, for example, sugar. These dilution example problems show how to perform the calculations needed to make a diluted solution. We need to remember the key idea behind dilution is that the number of moles of solute in the solutions does not change as the solvent is added. So the moles of solute prior to dilution is equal to the moles of solute after dilution. The concentration of the solution can be expressed in molarity. Molarity equals moles per liter of solution. Here's the formula for molarity, where M is the molarity, V is the volume, and the concentration. You solve for moles, and you're going to get moles is equal to molarity times volume. Since moles of solute prior to dilution equals moles of solute after dilution, we can use a formula, molarity times volume. So we can start off with our initial molarity and volume, and it's going to be equal to the diluted molarity and volume. Or we can use M1 V1 equals M2 V2. Or we can use the initial molarity and volume is equal to the final molarity and volume. It does not matter what subscript that you use. The best way to solve these problems is to list your variables, initial and diluted, or the initial and volume are 1 and 2. Remember, the initial and final concentrations must have the same units, and the initial and final volumes must have the same units, so they cancel out in your algebraic problem. Therefore, sometimes you may have to convert the values given in the problem before placing them in the formula. For example, if you're trying to find the final molarity, and you're giving the initial molarity, and you're giving the volumes. Say, for example, one volume is in milliliters, and your final volume is in liters. You're going to have to convert one of them so they're the same, so they cancel out. So here's an example problem. What's the volume of 5 molar sodium hydroxides needed to create a 100 milliliter solution of 1 molar sodium hydroxide? We're going to use this formula. The initial molarity and volume is equal to the final molarity and volume. It's best to list these values that are given in the problem. You may want to go through and highlight or underline the given. So here in this problem, we're trying to calculate the initial volume. So we're solving for V1 or the initial volume. So we're going to rearrange our formula. The final volume is equal to initial molarity times initial volume divided by the final molarity. Plug our values into our formula, make sure our units are the same that are going to cancel. And we get the initial volume of 20 milliliters. So this is telling us that 20 milliliters of 5 molar sodium hydroxide is needed to create a 100 milliliter solution of 1 molar sodium hydroxide. So we're going to start off with the 20 milliliters of sodium hydroxide, and we're going to add water until we get to 100 milliliters. So we're going to have to add 80 milliliters of water. Now we have 5 dilution problems to complete. As you go through this video, you can stop on each problem and work them out. When you finish, you go back to Teams, click on the Forms icon of Dilution Quiz, complete your answers, and hit Submit at the bottom. As you're reading through these problems, be sure to understand the given. Make sure you know the initial molarity and volume and the final molarity and volume and what you're looking for in the answer. Problem number 1. If you have 300 milliliters of 1.5 molar sodium chloride, how many milliliters of 0.25 molar sodium chloride can you make? You're going to use the formula, molarity and volume of the initial is equal to the molarity and volume of the final. You list your variables, and you can see which one is the initial and the final. Problem number 2. If you have a stock solution of the 185 milliliters of 1.5 molar lithium chloride, and you need to make 1 liter, determine the new concentration of the solution. Problem number 3. How much of a 7 molar hydrochloric acid solution can be made by diluting 128 milliliter of 14 molar hydrochloric acid? Problem number 4. What volume of 0.37 molar potassium chloride is needed to make 100 milliliter of 0.3 molar solution? Problem number 5. A stock solution of 3 molar sodium chloride is available. How many milliliters are needed to make 200 milliliters of 0.5 molar? And after you've answered all 5 questions, go back to Teams, hit the Forms icon of Dilution Quiz, answer the problems, and then hit Submit at the bottom of the quiz. Hope you enjoyed this tutorial.
That's all, folks.